Hi guys, welcome to my channel of Honest Sciences and Mathematics TV channel. Today we are going to look at the general reaction of a carbonyl compound. And in our previous videos, we had said that we can be able to represent a carbonyl compound using carbon that is attached to an oxygen at that specific point using the double bonds. And of course, in one of our videos, we had mentioned the concept of a polarity, whereby we see that in a carbonyl compound, this particular carbon at this specific point is going to have a partial positive charge, while this is going to have a partial negative charge. And we said that there's a pair of electrons which, of course, are going to be illustrated at that specific point. And therefore, this is going to have an effect of trying to have a preference on which type of compounds are going to react with this specific part of a molecule in carbonyl compounds. So if we try to illustrate this, we had said that there are different types of organic compounds which are going to fall under the category of these carbonyl compounds. And one of them that we had mentioned aldehydes, which can be represented using this carbon together with the radical and hydrogen at this specific point. And the second class of compounds which can be regarded as carbonyl compounds, of course, form a class of organic compounds which are referred to as aldehydes. And then we said that, of course, we can be able to as well represent what we refer to as carboxylic acids using this specific representation. And this as well forms a part of what we refer to as organic compounds respectively. So in this case, we are going to have aldehydes, ketones, carboxylic acid, and even what we refer to as esters. So therefore, for this basically is an ester. So therefore, we're going to have a carboxylic acid, and lastly, we're going to have what we call esters that we're going to consider in this specific case. So for aldehydes, ketones, carboxylic acid, and esters are going to fall under the category of these carbonyl compounds. Therefore, our general discussion is going to be centered around trying to look at ways in which they're going to react with other compounds, especially creating a focus on this particular section of this molecule. So therefore, in this case, if we try to look at the oxygen, we have two pairs of electron, which are going to give us partial negative charge at that specific point. And therefore, this is going to create an electrophilic section, which is going to be, of course, reacting with acids and the other, of course, which is going to create a negative section that is going to react with other acids and other electrophiles at this specific point. So therefore, we're going to see that we can be able to illustrate this section as a section that is going to, of course, react with acids. As we said, one of the definitions of acids, we can be able to indicate them as such, and therefore due to the nature of the charge that is being involved in this specific case, therefore it's going to interact with this section of the carbonyl compound. So therefore this section reacts with acids and of course what we have referred to as electrophiles, which I can be able just to indicate using that now that we understand what that initial stands for. So this section, which is a lower part that is positively charged, is going to be considered as a nucleophile, and therefore it's going to an electrophile, and therefore it's going to react here with bases. And we said that we can be able to represent a base using, perhaps we just use this general illustration. As we had said that an acid can be represented using that, we just use this one. And in most cases, we're going to see that it's going to also react with the nucleophiles, which we said are going to have a negative charge. They will have a preference at this carbonyl carbon at this specific point. So if you try to look at the general example, therefore, we're going to see that we can experience two types of reactions in this specific case for the carbonyl compounds. One of them is a nucleophilic addition reaction, and the nucleophilic, of course, substitution reaction that we have discussed in some of our videos. So I'm going to use a general example for this electrophile, this carbonyl compound, whereby I'm going to have that carbon shown with that oxygen atom at that specific point. This is going to react with another species XZ, whereby this is a polar compound that I can be able to illustrate as that. So I've intentionally put those charges so that we can be able to have a preference of where this section of the carbonyl compound, that specific part of that compound is going to attack. So therefore, we're going to have the interaction that is going to occur, whereby the Y is going to have a preference at this specific point, as we said, and the Z is going to have a preference at that specific point. So this is going to lead to the formation of a product that is going to have this particular a product illustrated as Z and OY given as that. So that is going to form a general way in which we are going to represent the reaction, nucleophilic addition reaction for carbonyl compounds. And if we try to look at this, it occurs in what generally we have referred to as aldehydes and ketones. So this nucleophilic substitution reaction occurs in aldehydes and ketones. And of course, using this one, we have illustrated the mechanism in a compressed way, but we can just have it illustrated in another way, whereby we are going to have this one carbon being given as that. So the first step, this is going to interact with a nucleophile, whereby the nucleophile is going to attack at this specific point, and this is going to move to that point, and this is going to lead to the formation of an intermediate that is going to, of course, appear as this, whereby we are graphing this Z attached to this specific point, and this is going to have a form of charge of a negative. So this species again is going to experience an interaction with the Y, which is positively charged, whereby it's going to pick on this specific Y, and that is going to lead to the formation of a final product that we have shown in this specific part to be that particular species. So that basically gives a first set of a nucleophilic addition reaction that is being experienced by carbonyl compounds. And then next we can look at the last example, which is going to basically entail the nucleophilic substitution reaction, which basically occurs in carboxylic acids and esters as a family of carbonyl compounds. So we're also going to use a specific example, or a general example, so that we can be able to understand how that one occurs. So suppose we have a carbonyl compound that is containing this specific parts of X and Y. Basically we can just use this one for a radical. So consisting of that radical and Y, which is interacting with a nucleophile that we can illustrate as such. So as we said that this nucleophile, of course, is going to attach at this specific point. It's going to substitute Z at that specific point, and we're going to have a product that is going to appear as a radical and a nucleophile attached at that specific point. And we're going to have this specific product which is going to be formed that is negatively charged as that. Now, for us to show the reaction mechanism in this particular case, as we had said, we are going to have this specific nucleophile attacking. We have two lone pairs of electrons. We are given the polarity of this specific as a partial positive charge, partial negative. Therefore, the nucleophile is going to attack at this specific point, and this is going to move to that particular point to form a negative charge intermediate. So therefore, if we try to consider that one, we are going to have this one as negatively charged, a single bond as such, and therefore we're going to have this one represented as Y, and we're going to of course account for the stereochemistry of this specific intermediate, whereby we can just represent this one as a wedge at that specific point, and this is going to form, of course, a bond that is facing away from us, and of course this is going to lead to the formation of that one charge at that specific point. So therefore, this is an intermediate that is going to be formed from the interaction of the nucleophile and that particular compound. And then this is going to lead to the formation of products. And of course, this can be used as a reversible reaction between the intermediate and this particular reacting species that is reacting the nucleus. So this is going to lead to the formation of a product that is going to be shown at that specific point. So we can have this particular species that was acting as a living group, as we had seen in the first case for the bromide, that was of course moving in our first case for the, as we were demonstrating for the SN1 and SN2 reactions. This is going to act as a living group, and it can be perhaps a halide or other molecules which you are going to see later in consideration of other factors. So basically that is the how we can be able to represent the general reaction for carbonyl compounds whenever we come across them, especially for aldehydes, ketones, esters, other videos, and kindly check on the link on the description box these various topics and deeper details. So that is it for now, guys. Bye. God bless you.